Oops, cut myself out of the picture. There I am. Okay, we're going to go ahead and I think it's been a while since I have and I'll get my act together here in 1 second. Are you seasick yet? Sick of me yet? Anyway, there we have a good old NFL collision, and this is kind of an appropriate time to be doing this lesson on head trauma and the forces of collisions in football and things like that. And basically, we're going to be looking at Newton's third law of motion and the conservation of momentum, two of the biggest theories in mechanical physics. All right, in classical physics, the conservation of momentum and along with the conservation of energy and Newton's three laws pretty much lay the groundwork for all of the physics that takes place. And as the NFL schleps along with its horrible PR, yeah, Alex Gordon had a concussion. Oh, wait, no, he didn't have a concussion. Oh, well, but we're still going to go through the protocols and everything. And then why? I think I think sometimes Andy Reid is. I mean, he's a much more knowledgeable football guy than I am by 1,000 times and understand. But sometimes he does the stupidest things I've ever seen. Why would you send your starting quarterback has already gone out on a uh, due to a concussion, but he passed the protocols. And I've read many independent articles and studies of the NFL protocols, and they are pretty much a joke. But anyway, and I always like how the gravitas that the announcers use and the analysts, the ex-player analysts whose brains are scrambled too. Adding, oh yeah, we're doing it. Yeah, right. Anyway, so with that as an intro, and then why Andy Reid sent him on a naked bootleg, and they're already aiming for his head. Every tackle they aimed at his head, as we did with all the others. So anyway, I've got to turn off my email, otherwise we'll get inundated here with emails too. So anyway, today we're going to look at Newton's third law. For every action, there's an equal and opposite reaction, and the conservation of momentum, which means after a collision, there is. I've got to turn off this email. It's going to drive me nuts. Anyway, so that means the momentum before a collision is equal to the momentum after a collision. And there are two kinds of collisions, an inelastic collision and an elastic collision. And most of the collisions that take place are inelastic. In other words, two things stick together, or they kind of stick together, then fall apart, those kinds of things. So without further ado, the first, let's go ahead and get started. I'll turn off this part. And here we go. Let's just kind of look at the slides. Okay, football. Force and players' heads undergo 98 G's of acceleration. 98 G's. For a comparison, driving into a wall at 25 miles per hour without a seatbelt resulted in 100 G's during the head windshield collision. So that's a tremendous amount of force. What forces, if he experiences 98 G's, F equals ma. Say the mass of the head is 5 kilograms. 5 times 98, about 4,802 newtons. That's a lot of force, or about 1,000 pounds. Well, close to 1,000 pounds of force. Okay, I've got you could either like download this slide and you could click on these, but I've actually made better recordings of these. And this will end the intro to this part. And so I will go ahead and back out here and you can watch these two videos. They're the next two in the track for you. Okay. Now I got to find it. There we go.